Welcome, everyone. My name is John Warren. I'm the Director of Admissions here at Columbus Academy. Thank you very much for joining us today for our Zoom at noon. Let's see. Just to let you know, this session is being recorded. It's not going to be pushed out and available in general on the web. However, we will use this if some family has a specific interest in our robotics and kind of our STEM program here. We will be sending this along to them. But I just do want to make that as a public statement. So this is today's series. Today is the next in our series of Zoom at Noons. We've had them on college counseling. We've had them on our service program. We've had them on our athletic program here. And today we're focusing on STEM. And when people ask Columbus, me as the Director of Admissions about our STEM program, I always kind of pause. I understand what they mean, but it's a little bit too trendy. It's too buzzwordy for me and my tastes. And what I try to talk about is in the context of our overall program. And our overall program, I would liken to an accelerated liberal arts sort of education. But obviously the sciences, mathematics, engineering, are not engineering so much in terms of the liberal arts, but our program really is a liberal arts sort of education where students can really focus lots of energy on any one of a number of different areas. And included in that is STEM. And I don't mean to demean it at all by the air quotes. Our program here is very robust and really student driven, as you'll hear. So I've got a few people joining me today. Tom DeVore, who is, I've got my notes here to make sure. Tom is an upper school physics teacher. He's the advisor to the Robotics Club. He's in his 9th year here at Academy, and he's the father of 3, including an Academy alum, and his daughter is presently a junior. And we also have Luke Howard, who is here. Luke is a middle school science teacher in his 2nd year here at Academy, and he also has quite a history of lacrosse, I understand. Isn't that true, Luke?
Yes, it's true.
Okay.
Right here at
And then finally, we have Sean Cullinan, and Sean has been, he is Academy's first Director of Technology, hired back in 1997. And has been very, very important. A lot of times, many times other schools, and Sean will tell you a little bit later on more about what he does, but at many schools, a director of technology is managing the hardware, the software, making sure that, you know, power cords are distributed and all that. And Sean does that with his team, but he has much more of a global perspective as well, and is really trying to make sure that technology really is an easy, is within easy reach for all of our students and faculty here. So with that said, I do want to get started, and to kick us off, we're going to have Tom DeVore talk a little bit about his robotics class in the high school and the robotics club. So, and a picture of Tom with the potato cannon that he can tell you about was featured in the slideshow earlier. So Tom, please.
All right. What I'll do, I'm going to switch to a screen share here so I can kind of give you a good picture of what's going on. And let me go ahead and blow this up. So what we have here is that in the upper school, I'm an upper school teacher. We do have a robotics club, and this robotics club is for 9 through 12. And I also teach classes in robotics and electronics. So the electronics class and the robotics class are both senior electives, one that we can build on the physics, build on the math that they've been doing up to this point. And these are project-based classes. All grades are project-based. And I really try to address a number of areas where the students might not have had experience with these before, to try to generate some interest and to see what they would like to do. So more specifics about this will be here in the next few slides. I also run the robotics club, which is 9 through 12. And I'll give more specifics about that as well. But basically it's about making a robot for a competition. We have an end goal, and the kids can pick a number from about 30 different events that they can build a robot for. And we supply the materials, the know-how, and they supply the manpower and teams to do it. So I'll start off with the robotics class first. In this class, I want to teach the kids about inputs and outputs. The genesis of this class is I have an engineering background, and I like the kids not only to see data, but be able to use the data, to make something with the data. So what I do is I use Arduinos, and I teach the Arduino programming language, and we then use inputs such as buttons, switches, force sensors, keypads, and we bring those into the Arduinos electronically, and the kids get to apply some of the electronics that they've learned in physics. And then we use those as outputs for speakers, servo motors, brushed motors, and LEDs. And the kids can actually program to do different types of activities. I teach them the difference between what a digital signal is and what an analog signal is, and how to use those as both the inputs and outputs. And the final project for this year, the final project is usually student driven, as far as I said, from either October, November, or December. There's lots of holidays in there. Please make a decoration that would represent one of these holidays. And the students would make a decoration for the holiday of their choice. And they had to have so many different inputs and at least 3 outputs, or a wireless, 2 and a wireless control to it. So on a few of these, this is one of my students this year, and he decided to make a lighted snowman that would actually have music to it as well. We did use Bluetooth and wireless communication. That's one of the things we learned in class. So let me just, whoops, let me go back. I'm sorry. Let me show.
Hey, Mr. DeVore, this is my project. It's a snowman. So the first thing is when I press this button, it toggles the lights on and off. So I'm not pressing it, and it's off. And the force sensor does the same thing. On, off. And then using a Bluetooth controller, I can play music. And I can also change the color of the lights. So I'm going to toggle the lights back on. And using the RGB controls, I can change the colors of the lights to whatever I want. Oh, I have to turn the on switch on first. So it doesn't do it by default. So I turn the on switch on, then I can do it. I can go to any color and like any shade.
Okay.
And
so in addition to that, with the electronics class, this was a prior year where the kids needed to make a project based off a motion robot. And this particular student, of course, I'm picking a good one here. This particular student made a gesture control robot. Watch how they move their hand. If you look on their finger, that's actually an accelerometer, which gives you a X, Y, or Z direction. So they're actually driving the car with the motion of their hand and some wireless technology that they learned in class. And so they would have built and programmed that in class, and it's a semester class, learning what they, basically applying what they've learned in class. So it's a nice application of it. For the robotics class, it's also a project-based class. We have the kids learn computer-aided design with the sole purpose of being able to make 3D prints. We have a lot of 3D printers I think Luke will talk more about that, but I have 2 of them in my area as well. And robotics techniques, and they will once again learn programming, but this time in Robot C. So just looking at a few things here, this is a student drawing that they had just from an early exercise where they learned how to make this and design it in CAD. The final project in the CAD part of this class of robotics was that the kids had to make a design like this, put it into a format that could be 3D printed, and then print it out. One of my students got so excited that they decided to actually film their project being made. And this is the Globe Theater that came out of it. They designed it on CAD and then printed it out, which was a very nice project.
She was huge into theater.
Yes, yes.
She was a big theater kid.
So, and they do that. They make them based off their interest. I just show them the tools to make whatever they want. And then they go ahead and follow through. So here is a robot, just one of the challenges that we have during the semester. And in this one, they've actually built this robot, wired the robot, and we're using NXTs, Lego NXTs on this one. And they program the robot to actually write, come on, I keep not hitting the play. There we go. And one of the assignments was have the robot write NXT. So that is 100% student built and driven. Then finally, for their final project, I give them a task of either collecting blocks or collecting something else and scoring them, and they actually compete against each other. The highest grade, the highest score in the class gets 100%. But there's other levels, like if you score over a certain amount of points. So this is 100% student design and made, and they picked all the electrical components, wired them, and all the building components in order to do this. So this is just a shot from one of the games, but it's just, once again, it's part of that robotics class that's offered to the seniors. And finally, there's a robotics club. Now the club goes for all ages, and we have done first in the past. We're currently working with the NRC, and the NRC is a competition that's held up in Marysville near Honda. It's the main sponsor, but it does get participants from 9 states. We typically have participated in this competition. Last April, we did not because of COVID, but the students have done very well. Every year we've been there, we've made finals. The last time we competed, we actually won the Honda Innovation Award, which was very nice for the most innovative robot. We basically took a competition where you had to shoot a puck in robo hockey. And the year before, the team that shot the puck the furthest was about 6 inches. We actually put pneumatics on ours, which is air controlled in a cylinder, and we could shoot the puck 30 feet. So we were doing rebound shots and everything else. So, I mean, the judges actually brought other judges over to see my team, but it was my team's idea, and I just helped them implement it. So it was actually a very fun competition that we went through. And you can see the kids are using controllers and some of the same Arduino technology that we talk about in class to help go through these. So currently we have a robo hockey team that's working for this April and a combat robot team. So these are 2 of the kids actually graduated last year, but we have more kids participating even this year. And that's what I have in the upper school for both electronics and the robotics.
Luke, maybe you can give a little bit about the middle school program that you work with.
Yeah, sounds great. So I will also do a screen share. I have just kind of a photo-based slideshow to kind of show us some things. And before we get started, like what you'll see on here is that it says Middle School Makerspace, STEAM, iDesign. So while I'm talking, I'm kind of speaking for also Todd Martin, who is head of the Middle School Makerspace and teaches the iDesign course while I teach STEAM here for the 7th and 8th graders. And before we start looking at some of the 7th and 8th grader projects that we have, one of what I would say both Todd and my favorite things about the middle school makerspace is that it services the entire school. So we work with everyone from 3-year-olds to up into the seniors. Sometimes, you know, we've dealt with some of the robotics kids coming over for thoughts, ideas, and all those kind of things. And so this space is awesome. This space is a resource with things like, as Tom was mentioning, we have 7 3D printers in here to go along with his 2. And then we have a laser cutter, we have woodworking tools. So we have a lot of different things, and then a lot of crafts, painting, all those kind of good things that a makerspace would have. And then what we also have as a service is Todd's ideas and thoughts, my ideas and thoughts. So when kids come in with different ideas from all across the school, we can implement them or and help them implement them if teachers come. And that's, I think, one of our favorite things is when you have a history teacher come in and say, hey, we want to do something around this theme, we can execute it. And their kids can do projects that are in history class that can use the makerspace. And so I think that's one of the most fun. So I'll show you some of the things that we're doing in STEAM and iDesign. I think that's one of the best uses of this makerspace is that we can go out and other classes like a history class, a math class can come in and use the space to create a project and alter their curriculum from just a textbook curriculum to now a hands-on curriculum component. And so the makerspace is much larger than just our 2 classrooms, but you'll get a sense of what some of the kids are doing and the projects and the ideas around them. And I do like that STEM in quotes, because yes, we are STEM based, but we're also hands-on. We want to get kids thinking, kids creative. And so we're not too focused on things like science and technology and engineering and math, but we want to combine all those as a larger whole to get the kids thinking in other directions. So this is like a cardboard challenge where the kids can just think whatever they want and then make it. And one chose to do a house. Another one where they could design their own camera. So this is a really open-ended project. And this project is based in it's the first project that Todd actually does with his students. And it just kind of gets their juices flowing, gets them thinking, and gets them in a hands-on mind that they really haven't got a ton of yet. And so I thought this one was a really cool one as well. This is a hand with movable fingers. And so there's rubber bands in there, and those are paper towel rolls. And so a hand can go inside there and move the fingers, which I also thought was pretty cool. And again, like, we don't come up with these ideas. The kids are just cardboard challenge. Here's some cardboard. What do you need to have it painted? And then this is a classic STEM project right here. This is the mousetrap vehicle, where with how you alter the vehicle with the mousetrap spring, you can either make it go really long and kind of slow, or it could go really fast for really short bursts. Find something in the middle, and the kids can kind of challenge around and figure out how they want to have their best vehicle. And then because we have fun with it, we also can make our vehicles things like Harry Potter, and you can see the little broomstick at the end. So there's a lot of different, we encourage that. So we don't just focus on how far we can make it, but we encourage the kids to be really creative and add that element of design to it as we're working with our 7th and 8th graders. And then this is a project, this is to start to show you. So the next 3 slides are about this flashlight project that I do with the 7th graders in STEAM. And what we do is they have design parameters, and this is their second true but first real experience with 3D modeling software. This is a Tinkercad software, so it's the middle school version of what Tom is doing in the upper school, but it starts to get him engaged. And that is when I started teaching 2 years ago, that's the first time 7th graders ever touched 3D modeling software. So they have some parameters, they 3D model how they want to make certain components of their flashlight. And then we do the electronics and soldering. And for the most part, this is their first time using electronics, first time doing soldering. So we do very basic, simple, just a switch, a light bulb, and a way to connect a 9-volt battery. And they do that as 7th graders. They learn how to solder for the first time, learn the basics of electronics, and really just try to start that initial foundation. And then here you can see the different components of their flashlight, their plastic flashlight now going together, fitting together, and the kids make that from start to finish as their final big project in STEAM in 7th grade. So That's an exciting one. That's a big one. And I really love teaching that one. And then this is our new project. This is just speaks to Columbus Academy and what we are able to do and the types of flexibility that we can have, which is this is the start of us creating mini putt-putt course for and the 8th graders do this as their big project in STEAM. And this is a modular course. It comes out, I'll show you, continue to show you different things. Kids are in the hallways building. Actually, all of the holes are in the hallway right now. And so that's fun. It's a thing where we can, especially with this year, it's tricky trying to have these things and deal with the coronavirus. And so we can still build, we can create, and this is on a scale, even when we play, it can be done socially distanced, but we can do still amazing, fun types of projects. And again, these are all student led. And this is their first iteration, and we can keep changing, modifying, and adjusting as we go. And so you can see tons of kids in the hallways. We have these large hallways that we get to take advantage of and keep them distanced while still building and having some fun. And we don't shy away from power tools here. So we don't allow the kids to use the power tools solely by themselves. Someone always has to be there and watching, but they do actually use them, gives them the confidence to be able to do their projects, learn them. So it isn't just they think of the ideas and then the adults do the work. No, they're there, they're in charge of making things go and making things happen. So you can continue to see. So this is a new project we just started this year. We're really excited about it, and we'll continue to move forward. And then the last couple slides here are just about, again, that outreach that we were talking about, and every different piece of the school, from things like 3-year-olds who come in and learn how the laser cutter works as they make name tags for themselves, to up to, these are, I believe this is a senior, might be a junior, and they're working on for their service goals. They're making blessing boxes. So these blessing boxes are pantries that fill like different foods, dry goods, those kind of things. And they come in here with their service. This is Todd and I designed the boxes, and then Todd's been working with them to help them build it. And so they are building it from start to finish, painting it, and then installing these in a variety of different places. So they're able to come in and make and build in here. And so in the same space that I'm in right now, we teach middle school classes, we have lower school, we have 3-year-olds, and then we have seniors coming in and making blessing boxes. And so that is it almost being done. And like I said, that's my favorite part about the middle school makerspace, is how versatile it is and how it really helps anyone in the school with any kind of project. We can come in and use it, and they can use it as a resource and use us as a resource. And then we get to teach some pretty cool classes on top of that. So that's my PowerPoint presentation.
Well, thank you, Luke. And right now, we're giving tours after school. We're just about to start, I think. We're talking about being able to start tours or have tours during the school day. But I was giving a tour over the weekend and then yesterday, and it is so much fun to see those putt-putt golf set up in the hallway. It causes great discussion, and people really understand what it's all about. So. In any case, now I'd like to turn it over to Sean Cullinan in just a second. But first, if attendees, if you have any questions that you'd like to ask, please do put them in the chat. I will moderate that piece. But right now, I'd like to introduce Sean Cullinan, again, our Director of Technology, and He'll talk about a little bit about the philosophical stuff. But again, this is just a crucial piece that Columbus Academy really is going. We're trying to expand and make sure that all students have lots of opportunities to follow their passions. I see this slide. I know what's coming. Go ahead, Sean.
Thank you, John. So our department gets to play a really neat role in the school, and to take some of the things that we've heard from Luke and Tom, and to then expand that and make it available to students for them to use to do the things that they're passionate about. And so we started a program called QuestWorks, where students can apply for grant money to work on whatever they they're interested in. If they want to build a drone, if they want to build an electric skateboard, an aquaponics system. We've had students build underwater drones. Those students building an intelligent pot, planting pot for with sensors that will determine a nutritional value of the soil and moisture content of the soil and give feedback based on those inputs. And so we've been able to start this really neat program where we grant students. We just picked a number out of the sky, $200 per student to build the things that they're interested in building. We found that number to work really well because students can do interesting projects for $200, but most of our students want to do projects that cost more than that, and so what they will then do is they'll go and they'll partner up with other students, friends, and bring them along with them. And so we might see a project with 4 or 5 students involved, and those students will get $800 or $1,000 to then work on their project. And the nice thing about that is that collaborative invention then takes place, and so the students then bring their skill sets together on projects that they are intrinsically motivated about. And we've seen just students go as far as they want with those projects. They can work on the projects before school and after school, on weekends, over break. They can take the project home with them over the summer. And we've actually had quite a few students who have graduated from the school and requested to then take their projects along with them into college and have continued working on them in college. And here we've got students working on augmented reality and virtual reality, and we'll build arcade machines where students can code the games and then make those available in our hallways for other students to then come along and play. And it's just rather than working for a grade or a club or a competition, which all have high value, but these are students that then get to go beyond that and work for their own intrinsic purposes. And John, I'll turn it back over to you on that.
Okay, great. So Becky Anderson is asking that she heard STEM and STEAM, and is there a different focus depending on grade? I'll let Sean talk a little bit about this because it is a progression. And we have, Sean, maybe you can talk about the innovation stations that are in the hallways, particularly in the lower school. And again, not everything that we're doing here is super techy. One of the projects that Sydney Lawrence, was it Sydney Lawrence who did the little book library?
Library, yeah.
So not everything is super tech, but anyway, Sean, if you can talk a little bit maybe about lower school, middle school, and upper school.
Yep. So another program that we were able to put in place, we call them interactive displays. So they're in our hallways, and we've tried to make our hallways interactive and engaging. And so we might put out a twist tie art gallery or a Rubik's Cube art gallery, robotics stations, coding stations, stations where students can, as they're walking through the hallways, actually interact with a project, and they interact with the project in collaboration with really the rest of the school, including students from all 3 divisions, including parents that might walk down the same hallways and interact with the same interactive displays. And so over time, you'll see some really cool engagement, some really cool end products where a student might begin work on maybe a big Connect roller coaster, but they've only got enough time to get it so far, and then other groups of students and other groups of faculty and parents will come by and take it even further. And it's really been neat because students then have to they own their engagement with that interactive display, but then you also have to give up ownership of it to the other people in the community who come along and also engage with it. And so people may take projects in a variety of different directions that you may not have thought about originally, which has been a great way for us to kind of grow and learn and think in new ways. A lot of our projects, so again, we do want to include the sciences and the technologies and the engineering components, the mathematical components. John's a math guy, you know, he's trying to minimize the
No, go ahead.
the math brain and the arts and value all of those disciplines and what they bring to the table as we engage in the creative process and the design process and the engineering process.
Right. And the last thing I'll mention is each, you know, every grade here at Columbus Academy, I'm actually a graduate. I graduated in 1980, and education was much different and much has evolved since. Back in 1980, when I graduated, I've said this many times, it was actually about trying to gain as much knowledge and facts as you could, right? I mean, the idea was if a student had more knowledge right at their fingertips, quick recall, memorization, the whole deal, then you were going to kind of win and beat the person who didn't have quite as many facts and figures at their fingertips. What's so different now is, you know, the technology in general. The projects, the things that we used to do in school just don't have much value now. Memorizing all 50 states with their capitals, correct spelling, I'm proud that I know all that, but those aren't the sort of, that's not the intrinsic value that's going to help a student succeed in life as we know it. Instead, it's about collaboration, cooperation, creativity. And so even thinking about the progression down in the lower school, I think it was a second grade hallway last year. There were kids, they'd gone outside, they have these lots of outside activities, but they were supposed to collect sticks and come home and come back to school and build a house or some abode out of those sticks. And it was fascinating to see, you know, the design challenge that happened at even that level. Then you go to grade 8, and one of my favorite tours ever was right before the 8th grade were heading off to Washington D.C. on their DC trip, and Amy Seymour in English and Laura Miller in social studies history, and Todd Martin in the makerspace. They were supposed to design a new monument for Washington. So they were using their history knowledge, what monuments are already there, and celebrating what events are in US history that ought to be celebrated, where is there a need, a lack. And so they wrote a position paper for English class, why this was important. They've done the research in the history class. And then in the makerspace, they actually had to design a scale model of this. And there were kids who used Fortnite to build stuff. There were kids who used the 3D printers. There were kids who were, you know, sawing and doing all sorts of stuff like that. And it was just fabulous to see the interdisciplinary nature. Again, that's not unique per se to Columbus Academy, but we are really doing it quite well. And it shows you how important that these skills are, and that it's not all just, you know, rote memorization. And we're really doing a good job with it. I'm sorry to digress so much. There's another question.
Well, you know, I would like to address one thing too, is that we teach them tools, and that these tools are available. So like for last year's play, there were people that helped design and make the Beauty and the Beast rose, which was actually, they made their own box with switches that radio transmitted the signal to the flower to drop rose petals. All right. So that was done in the play. I know a current project I'm working on right now with my advisory, is that we came up with our favorite quote for our advisory, our favorite inspirational quote. And we said, we'd like to hang this in the room. And they all seem to agree on the quote. So what I'm actually going to do is I'm going to go back to Luke over in the middle school makerspace because he has the laser cutter. And I'm actually going to engrave and cut out these quotes for the students, not only for my room, but they actually requested if they could have one for home as well. So we're really showing them tools that are available. And for me in Robotics Club, they're going to apply it to robotics. But if they choose to apply it to theater, or if they choose to apply it to working with their friends, to some other mission that they would like to do, they can apply these tools and creatively use them. And that's really what it's about here, is what tools are available, how can you apply those tools, and let the students be creative in how exactly they do it.
The question in the chat here is, are the projects part of the standard curriculum, or do students need to join the club? What is the criterion to join project teams? Sean, in the high school, the QuestWorks program is open to any student 9 to 12, grades 9 to 12. Luke, isn't there a science Olympiad in the middle school science Olympiad team?
There's not Science Olympiad anymore.
Oh. Ooh.
Yes, but to answer the Becky's question, when she says STEM and STEAM, is there a different focus depending on grade? It's the same focus. So Todd and I, we really talk about what are the things that we want to have the kids go into upper school with, and then how are we going to do those things? So in 7th grade, we have the same core types of things like learning 3D modeling, learning how to work with hands-on, learning creativity, learning the design process, those types of things, and then attacking it in a 7th grade manner, and then improving upon those skills in 8th grade manner. So really what Todd and I are trying to do with those STEAM classes is have a larger set of skills and then attack it in a couple of different ways over a couple of different grades and build on the same core set of skills is what we're trying to do. So I hope that answers Becky's question. And then I know for our projects, the kids are in our projects and they're doing our projects. And then like everyone else has said, there's the other projects outside of the curriculum, which is what's amazing about CA, is that you have the opportunity to do all these projects in your class, and then you can go outside your class and do even more projects. Like Tom's awesome discussion about that rose petal, that thing was amazing.
I mean, that was really cool. I forgot about it. All right, any other questions? All right. Well, I do want to make a plug for a couple things that are coming up. This evening is a lower school virtual open house. We were going to have a middle school open house this coming Thursday, but it has been moved to a week from today on the 12th at 6 p.m., a virtual middle school open house. And then on the 19th of January, 6 p.m. is the virtual upper school open house. Obviously, the admissions office is interested in talking with anyone interested in Columbus Academy as a school. As I mentioned, I think starting very shortly, we will be giving tours during the school day. So if that is something that your family is interested in, please keep listening, because I think that change will come pretty quickly with the new year. And then finally, let's see, next Tuesday at noon, we have Jen Conti, who is our Director of Internships and Outreach, and she will be discussing, again, it's a program that's much more geared toward upper school, but she will be talking about internships here at Columbus Academy. So we hope you'll join us for some of those events. As I say, often, all of these are meant to be beginnings or continuations of conversations with you, the prospective family. So please don't hesitate to give us a shout and find out more. Thanks so much. Particular thanks to Luke and Sean and Tom for helping us today. Nancy Velasquez, as always, for the technical assistance behind the scenes. So thank you very much, and we look forward to hearing from you. Bye-bye, everyone.
Thank you.